All right, logarithms and exponents. This is one of the easier chapters, I believe. So let's start off with what is the idea of a logarithm. So we all know about exponents, and logarithms are basically the opposite of exponents. So let's review exponents first. So if you have 2 to the power 3, that basically means 2 multiplied with itself 3 times. So this will end up being 2 times 2 times 2, which is 2 to the power 3, which is 8. Yeah. Now, the main properties of law of exponents is that if you have 2 to the power 3 squared, whole square like this is nothing but 2 to the power 3 into 2, which will be 2 to the power 3 into 2 is 6, so 2 to the power 6, which is 2 multiplied by itself 6 times. Then if you have 2 to the power 3 into 2 to the power 2, that'll be 2 to the power 3 plus 2, which will be 2 to the power 5. And then we have 2 to the power 3 divided by 2 to the power 2, which will be 2 to the power 3 minus 2, which is equal to 2 to the power 1. Yeah, those are the main properties of exponents. Then we have the idea, which is a bit more, a bit harder, I guess. So this will be 2 to the power 3 plus 2 to the power 2. How would you do this? Well, basically, to simplify this, you can take 2 squared common and write it like this. And I'll explain it to you in a simpler manner. This is nothing but 2 into 2 into 2 plus 2 into 2. And we can take this and this common, which is nothing but 2 into 2 squared plus 2 squared. Then you take 2 squared common, 2 plus 1. So this will just end up being 2 squared into 3, which is nothing but 12. So this might be an easier way to just simplify exponential equations, I guess. Yeah. Now, what are logarithms? So I'll just erase this slide over here. What are logarithms? So let's just take a simple example, which is, let's say a is equal to b to the power x. Then to find the value of x, there are two ways in which we can do this. So let's assume 2 is equal to, or 2 to the power x is equal to 8. What we can do is make the bases equal. So this is base 2, right? So we need to make this equal to base 2 to the power n, let's say. And if we are able to successfully do that, then the powers will be equal. So basically, we'll get 2 to the power x is equal to 2 to the power 3, right? So n is equal to 3. And x is equal to 3 will be the answer for this equation. Some other cases would be when you have something like a is equal to b to the power x, where you have 2 to the power x is equal to 9. How do you solve this, right? In this instance is when we get the idea of logarithms. So this is the same thing as x is equal to log of a base b. So basically applying this formula over here tells us that x is equal to log 9 base 2. If we apply the same thing over here, I'll get x is equal to log 8 base 2. And this is equal to 3. This is going to be 3 something. Yeah, those are just the ideas of logarithms. Now, another thing I want to tell you is some property of exponents, which is that if you have a to the power n and b to the power n, if these two are equal, then they can only be equal on two bases, right? That let's say that a is equal to b. If a is equal to b, then m has to be equal to n. Okay, let me rewrite it, make it a bit easier to understand. If you have a to the power n and this is a to the power m, then this basically means that n is equal to m. Another case is when a is equal to a to the power n is equal to b to the power n. For this to be the case, a and b are equal. That is just another way of solving it, another technique that can be used. Otherwise, one common solution for most of these equations will be that the power is equal to 0. And that is because a to the power 0 is equal to 1. Anything to the power 0 is equal to 1 except 0 to the power 0. That's undefined. We don't get into that. Now let's talk about the graphs of exponentials, and then we'll talk about the properties of logarithms. So the normal graph for an exponential is, well, okay, this is going to be 0. Let's say we have 2 to the power x. 2 to the power 0 is 1. So it's always going to start from here. And then it's going to go, sorry, and then it's going to go like this. It's going to be a curving upwards, right? So if you have over here, let's say the value 3, 2 to the power 3 is going to be 8. Let's say 2 to the power 2 is going to be 4, 1 is going to be 2, and this is going to be 0, which is 1. So if you look at it, the rate at which x changes is less than the rate at which y changes, which is why it's going to be curving upwards, and the gradient is going to be non-constant. It's going to be increasing at a constant rate. Now, this is not like the quadratic function, which is like this, because when it comes to exponentials over here, they decrease because 2 to the power minus 1 is nothing but 1 by 2, right? So these are just some other properties that I should talk about. 2 to the power minus 1 is nothing but 1 by 2. And then let's say 2 to the power minus 3 is nothing but 1 by 2 to the power 3, which is equal to 1 by 8. Another property is square roots, which is basically fractional indices. So 2 to the power 1 by 2 is nothing but root of 2. 2 to the power 3 by 2 is equal to root of 2 cubed, because 3 is the numerator. You can write 2 to the power 3 by 2 as 2 to the power 1 by 2 whole cubed, which can be written as root of 2 cubed, and this cube can come inside or outside, it's the same thing. That's just one other property of indices, of exponentials. Now let's get to the properties of logarithms. If you have log of m, this basically means that the base is 10. And if you have ln of m, that means that the base is e. E is Euler's number, which is 2.7 something. And this will be in your calculator for the calculator papers. Now let's say we have log m plus log n. This is going to be the addition rule, which is log of m into n. If it was minus instead, log m minus log n, then this is going to be log m divided by n. So the one that gets that n, which is the minus, is going to be the denominator. Then we have log of n to the power m is nothing but m into log n. That's going to be the third rule. Now, the fourth rule is the most complicated one, or the hardest one to master, even though it's really not that hard. The rule is the change of base rule. So let's say we have log of base m of a. If we want to change the base, which is this m over here, to let's say 10, so we can just write as log of something, we're going to have to do this. It's going to be log a by log m. That is the change base rule. So I can have c over here, whatever. Basically, in this rule, to change the base, there'll be a fractional value in which this comes in the numerator, log of the base which we want. This comes in the numerator and this comes in the denominator, like this. That's the change base rule. Okay, now let's solve some questions. Log of x minus 2 base 2 is equal to log of x squared minus 6x plus 12 base 4. So to solve this, we need to change the base. Let's change this one to log base 4. And to do that, we write log base 4 of the inside value, x minus 2, divided by log base 4 of 2. And this is equal to log base 4 of x squared minus 6x plus 12. Now, what is this value going to be? This expression is basically telling us what 2 to the power of what is equal to 4. So, yeah, if you just put this in your calculator, for example, um, it's going to be 4 to the power of what is equal to 2, which is going to be square root of 4. So log base 4 of 2 is going to be 1 by 2. Okay, I'll restart that. It's a bit bad. Um, okay, so this is one question that I wanted to discuss. Log base 2 of x minus 2 is equal to log base 4 of x squared minus 6x plus 12. So log base 2 of x minus 2 is equal to that. What we can do is change the base. And to change the base, we'll have to, the easy one to change is the base over here. So instead of writing log base 2, I'm going to write it as log base 4. So this is going to be log base 4, x minus 2 divided by log base 4 of 2. Now, what is this expression equal to? Let's solve it over here. Log base 4 of 2 is equal to x. So how can we use the formula that I showed you previously, which is that if a is equal to b to the power x, then x is equal to log of a base b. Using the same logic over here, this is what we have. We need to get it in this form to solve it, or we can just use the calculator. But to solve this, is going to be 4 is going to be b. So 4 to the power x is equal to 2. Now what is that value going to be? Square root of 4 is equal to 2. Square root is nothing but to the power 1 by 2. So x is equal to 1 by 2. So this expression is equal to 1 by 2, right? So let me write that. Um, if it's 1 by 2 in the denominator, then it will go to the numerator as 2. So it's going to be 2 into log of x minus 2, right? So this value is equal to 1 by 2, which I'll take to the numerator as 2. So I'm going to just scratch this out, just forget about that. This is equal to log base 4 of x squared minus 6x plus 12. Now, what we need to do is use the power rule of logarithms, which will mean that this power will come up over here. So this will be x minus 2 squared. And that will give me log base 4 of x minus 2 squared is equal to log base 4 of x squared minus 6x plus 12, whatever that is. Now we can cancel out the log base 4, log base 4. So this goes out, this goes out. And we'll be left with x minus 2 whole squared. I'm going to erase all the ink on this slide. We get x minus 2 whole squared is equal to x squared minus 6x plus 12. That's all we need to solve now. So x minus 2 whole squared is going to be x squared minus 4x plus 4 is equal to x squared minus 6x plus 12. This x squared cancels out. We can take the 4x on the others. Okay, let's take the 6x to the left hand side to give us 2x, and this 4 will go on the other side to give us 8. So we get x equal to 4 as our answer. There's only one solution to this. Now you can put this on your calculator and try that out. Log base 2 of 4 minus 2 is going to be 1. Log base 4 of 4 squared minus 24 plus 12 is going to be 1 as well. So x is equal to 4 is the correct answer. All right. This is the second question. X to the power ln x is equal to e to the power ln x cubed, whole cubed. Now, one property that I should mention is that ln of e is equal to 1, and I'm going to be using that over here. So let's take the natural log on both sides. Natural log of x to the power ln x is going to be the natural log of e to the power ln x cubed. So I'm going to take this down over here. This is going to equal 1, and this is going to come down over here. So that's going to be square. And next, ln of x into ln of x is ln of x squared. And this is going to be ln of x cubed. Now we need to solve this equation. There are two ways to do this. The simpler way is to make a substitution. So I'll be using that method. That ln of x is equal to y. So I get y cubed minus y squared is equal to 0. Take y squared common. Y minus 1 is equal to 0. So we get y is equal to 0 or 1. Now let's put this over here. Ln of x is equal to y, which means that if you put e to the power ln x is equal to e to the power y, this over here is simplified to give us just x. So x is equal to e to the power y, and that is nothing but y is 0 and y is 1. So e to the power 0, e to the power 1 will give us 1 comma e. Those are going to be the solutions to this equation. And the last thing I'd like to discuss is the graph of logarithmic curve, which is going to be something like this. It's never going to, the y value is never, the x value is never going to be 0, because ln of 0 is error, right? So we just take this as an asymptote value. This over here is the asymptote. This is always going to be 1, because 3 to the power 0, 4 to the power 0, e to the power 0 is always 1. And it's always going to go like that. That's going to be the shape of the graph. And that's it. Thanks for watching.